Hi everybody, Dr. Stevens here with another video for 291. This one about the Stanbridge Pharmaceuticals problem. This will actually be going across two videos. In this particular one, we're simply looking at formulating a new linear program and getting that program into Excel. So it's reviewing some skills that we've already discussed. In the next video, we'll be using the results from this video in order to be able to conduct a sensitivity analysis on that same problem. So let's go ahead and get started. You run the Stanbridge Pharmaceutical firm, and they have a rush order coming in. We have a client that wants 7 ounces of a new wonder drug called Tachyon and wants it fast. In fact, wants it today. She's willing to pay up to $300 per ounce for this drug, but you'll be charged a $30 penalty for every hour it takes you to fill the order. We are talking rush. Fortunately, you have a pretty competent staff to help you on this situation. Based 3 chemists that can work for you. The senior chemist works 8 hours per day, but can work up to 2 hours overtime. He gets paid $50 per hour for regular time and time and a half, $75 per hour for overtime. But he can crank out a half an ounce of Tachyon per hour. The junior chemist also works an 8-hour regular day and also works up to 2 hours of overtime. She only is paid $30 an hour for regular time, but also gets time and a half for overtime, $45 per hour. She's not as fast as the senior chemist. She can only make 0.2 ounces of Tachyon per hour. Finally, there is the lab tech. He can work as long as the junior chemist is around to supervise him. He gets paid $20 an hour regardless of how many hours he works. And he can crank out 0.1 ounces of Tachyon per hour. Our job is to figure out how we can make as much money as possible, satisfying the order that we've got, without breaking any constraints. So let's see if we can formulate this thing and put it into Excel. Okay. Here we are in Excel, and let's see if we can pull off a twofer here. Both formulate the program and stick it into Excel at the same time. Actually, this focus is on putting things into Excel so that we can do some sensitivity analysis, but we'll do a little formulation here at the same time just to make sure that things are working okay. It's a good review. So, what variables do we have in this problem? Well, something like this. I have ounces made, the total amount of Tachyon that we're going to make, and tote time, which is the number of hours it takes to do it. Sen reg and sen over are the number of hours of regular and overtime, respectively, that the senior chemist uses, and June reg and June over are the number of hours in regular time and overtime that the junior chemists use. Tech reg is the number of hours that the lowly lab tech works. Now, I don't know what the optimal values of these variables are going to be. That's Solver's job to find. But for right now, I'm going to stick some numbers in there just as placeholders. It's nice to be able to use those to check your work. Even if they're not feasible values, let alone optimal values, it's still useful. So there are some numbers, and now we're ready for the objective. What's our goal? To make money, lots of it. So here's our goal. Maximize profit. Every ounce that we make of Tachyon brings us $300, but we have to pay a $30 fine for every hour it takes us to make it. We have the senior chemist making $50 an hour during regular time, time and a half, $75 an hour during overtime, and the junior chemist makes $30 an hour, but also time and a half, $45 an hour during overtime. The lowly lab technician only makes $20 an hour no matter how long he works. Okay, how about constraints? Well, the first constraint I want is going to actually be to figure out how much of this Tachyon I'm making. It'll look something like this. The ounces made are 1/2 ounce for every hour that the senior chemist works, 0.2 ounces for every hour that the junior chemist works, and 0.1 ounces for every hour that the lab tech works. But this constraint as written can't be put down in my table down here because it's not in standard form. So I'm going to multiply through those parentheses to get rid of those, and then I want all the variables on one side and all the constant terms on the other. Well, if you look at this constraint, there isn't a constant term. There isn't a number by itself. So what I'm going to do is to take this expression and subtract ounces made over to the right-hand side. So it'll say all of this minus ounces made equals 0. Then I'll just flip the left and right-hand sides to put it into this constraint down here, like this. All of that stuff minus ounces made equals 0. And once I have the variable ounces made defined, I can use it to add my next constraint, that the ounces that I make has to be 7 ounces. Piece of cake. Now, how about time? Nobody can work longer than the total time of the project. That's certainly true for the senior chemist. Senior regular time plus senior overtime has to be less than or equal to total time. Again, not in standard form. I need all the variables on the left, so I'm going to subtract tote time to the other side and put that in my table. Here's senior reg plus senior over minus tote time less than or equal to 0. And of course I'm going to do exactly the same thing for the junior chemist. Like that. Junior reg plus junior over has to be less than or equal to tote time. I've simply subtracted that tote time over to this side of the constraint. Alright, there's one more that's kind of like that, which is this one. Remember that the lab tech can only work when supervised by the junior chemist. So the lab tech's time has to be less than or equal to the total of the junior chemist's time. Once again, I'll subtract off these terms to move everything to the left-hand side. The constraint will now look like negative june reg minus june over plus tech reg less than or equal to 0, because the june terms were moved over to the left. The remaining constraints are really quite simple. They simply say that no one can work more regular time or more overtime than they're allowed. That's 8 hours for the chemists for regular time and 2 hours for the chemists for overtime. Good enough. Now let's put it into Solver and figure out what the best answer is. The objective function is simply, of course, my profit, which is right there. This is a max program, not a min, so I can leave that radio button where it was. And for my decision variables, I'm going to move the box over here so that I can choose them. Click into the decision variables cell, and then drag over all those red boxes to say those are my decision variables. All that's left is the constraints. Again, let me move my box out of the way so I can see all of the left-hand sides and the right-hand sides of my constraints. I'm going to click in the constraints box and say Add. Now the first two constraints are equalities, so I can put them in together. The left-hand sides of those two are these two values. Then I want to say equal, and they're equal to the corresponding right-hand side values. Since I have more constraints, I'm going to hit the AND button, or the Add button, and now all of the remaining constraints are all less than or equal to. So I've clicked in this left-hand box here, and I'll drag it down over all of these left-hand sides, then go to the right-hand side box and drag down over all of these right-hand side boxes. I already have less than or equal to as the relation, so that's good. And since those are the ends of my constraints, I'll simply say OK. By the way, if you hit Add by accident, don't worry, you can hit Cancel and get right where I'm going right now too. Like that. I already have my unconstrained variables non-negative. I have that I'm using the simplex method, so I can say Solve. And here's my best answer. I make $934 in 9.2 hours by having the senior chemist work 8 hours of regular time and 1.2 hours of overtime, while the junior chemist and tech work only regular hours during the 8-hour day. Total money, $934. And that, ladies and gentlemen, is as good as it gets.